Hello everyone, you are welcome to this class. So in this class, we want to look at another topic that is plane shapes and symmetry. So when it comes to plane shapes, in this video we'll be looking at the following objectives and see where we can go. So if the video is too long, we'll have to stop and continue in the next video. So we look at the meaning of plane shapes and polygon. Then we look at types of polygon. So we also look at how to recognize different types of plane shapes. So recognition of plane shapes is also there. Then we look at the symmetrical properties of plane shapes. And the last one will be properties of plane shapes. We'll be looking at them one by one and be looking at their properties and see what are their features or their characteristics that makes them different and what makes them to be common. So those are the things we'll be looking at in this video. Uh, and let's get started with the first one. So when it comes to plane shapes, let me adjust this. All right. Okay. So a plane shape is also called two-dimensional shape. Why is it called two-dimensional shape? Because it has length and breadth. Just like when you have a line is just a one dimension, which is it only has length. It only has length, while a plane shape has a breadth and a length. So that's what makes two-dimensional shape different from one-dimensional shape, which is a line. So when you have a flat surface, so flat shape are what we refer to as what plane shape. I hope that is clear. Then I've explained this. So a plane shape may be defined as a two-dimensional shape which is bounded by sides and lines. So a plane shape is a two-dimensional shape that is bounded, that is surrounded by what? Lines, which are also referred to as what? Sides. Right? So that is what we refer to as what? Plane shape. Then let's now look at its polygon. So a polygon is also a plane shape with at least three sides. A polygon is also what? A plane shape with at least what? Three sides. So that is a plane polygon. So polygon, when you talk about polygon, I also talk about plane shapes. We are referring to the same thing. So they are also flat shapes. They are plane shapes. They are plane surface. For example, the floor of your room is a plane. It's a plane surface, right? So the shape you can get from the floor of your room is a plane shape, all right? It's two-dimensional shape because the floor of your room you have dimension of what? Length and what? Breadth. I hope that is clear. So that is what refers to as plane shapes and polygon. You can see the difference between the two now. You can see that they are the same. Plane shape and polygon, we are referring to the same thing. But in this video, we are not looking at polygon specifically, but we're going to look at some types of polygon that we have. We're looking at some types of polygons that we have. So let's look at types of polygon. You know, I said polygon is a plane shape with at least, that is the minimum shape you can see in a polygon is what? Is three sides. So and that is a triangle. So when it has three sides, it refers to as what? Triangle. And also, so the next one is quadrilateral. So a quadrilateral is a four-sided plane shape. So any shape that has four sides and four angles uh, is referred to as a quadrilateral. So example of quadrilaterals are rectangle, square, trapezium, parallelogram, rhombus, kites. They're just six. So we are still going to look at those ones in details later on in the video. Then we have pentagon from the word pent, which means five. So quadru means four. That's why you say someone gave birth to quadruplet. Quadruplet means that someone gave birth to four children at the same time. You understand? So twins is what? Two. If you hear the word tri means three. QUAD means four. Quadru. So quadruplets means four children. Then pentagon. So if you look at penthouse, so that has five sides. You understand? So pentagon means five sides. So a polygon, that is a flat shape, a plane shape with five sides, is referred to as what? Pentagon. Then the next one is a hexagon. So hexagon is a plane shape with six sides from the word x. So x there means six. So that's six sides. Then heptagon Heptagon means a polygon or a flat shape, a plane shape with 7 sides. Then octagon. So from the word octal, even you have done music in school, so you notice that we have what we call octal in the symbol, so which means eight trebles. So in this case, octagon means eight-sided polygon or eight-sided plane word shape. Is that clear? Then nonagon from the word nine. Nonagon means nine sides, nine-sided plane word plane shape. All right. So decagon, decagon is from the word decimal. This one is derived from the word decimal. So decagon is a plane shape with what? 10 sides. Then we also have duodecagon. Duo means 2. Then decagon means 10. So when you have 2 plus 10, that gives 12. So that's why this one is what? 12-sided polygon. Then we have hexadecimal. So hexadecimal means hexadecagon. Sorry, hexadecagon. That's what I want to write there. Let me change it. That is hexadecagon. Hexadecagon. So from the word hexa, so we can see we have hexagon. So we now have hexadecagon. That is 6 plus 10. That gives what? 16-sided polygon. I hope this is very clear. Now, we are not going to go into details of this. We are still going to have a separate topic that will deal with polygon in details, right? So just wanted to show you different types of polygons and the number of sides they have in this video. Is that clear? So the next one is to look at types of plane shapes. I want to identify the plane shapes that we have. So and these are the types of plane shapes we have. We've shown you can see triangle, which is a polygon, is also a plane shape. You understand? So if you say polygon, plane shape, we are referring to the same thing. So if you look at these, we have 8 types of plane shapes that we have here, right? So that is for plane shape and a polygon. So here we can see we have triangle, which has 3 sides. Why the rest, apart from circle, has 4 sides? So the rest are quadrilaterals, except circle. Circle is separate. So triangle has 3 sides. Rectangle is rectangle. We have square, all right? We have circle, we have parallelogram, we have rhombus, we have kite, and we have trapezium. Now each of these will be treated separately. We look at their types. Triangle has types, right? Rectangle has no type, but we're going to look at their properties. Those have different types. Trapezium too has types, right? And which one again? And that's all. So we only have 2 of them as types, which is triangle and trapezium has types. So we're going to look at them one by one and explain them. But before we go into the details of their properties, so there's need for us to look at these concepts and the concept of symmetry, which I made mention of. So the concept of symmetry. So we're going to look at that one as well. So let's look at that one before we move on. So we look at its symmetry. That will be the next one. Symmetrical properties of plane shapes. So when it comes to symmetrical properties of plane shapes, so we are referring to when you can divide a plane shape into 2 equal parts and the half can overlap, can fit into the other parts. So when a shape can be folded so that one half fits exactly on top of the other, the shape is said to be symmetrical. So the folded line is called the line of symmetry. Now, when it comes to symmetrical, we have 2 types. We have uh, line of symmetry and order of rotational symmetry. So we're going to start with line of symmetry. So the line, when you divide the shape into 2, is referred to as a line of symmetry. Let's look at this and see what we're going to get. Now, if I should cut this plane shape, if I should cut it into two, if I should divide it into 2 here, so let me divide it and see what we're going to have. So when I divide it this way into 2 equal parts, you see what I'm going to get. So you can see I've divided this into 2 equal parts. So the line I have there, So you can see that if I should fold this and place it on the other one, I'm good. This second part, the first half, will overlap, will fit exactly on top of the other one. So that is what we say. This rectangle here is what symmetrical, and the line that divides it, this line is what we call the line of what symmetry. So we're not going to be looking at their properties. So how many lines of symmetry does this have? So we divide it into two. So we can also divide it and in another way. So if I want to divide it again, I can have it divided in this form. So if I have it divided here, I can divide it here like this. So I can divide it like this again. So if I divide it this way, I'm coming. So you can see what we have. So this one is has also divided into another form. So if you fold it from the bottom here, from the bottom and upwards, it will overlap as well. So how many lines do we have here? We have, this is the first one and this is the second line. So it has two lines of symmetry. Then when it comes to order of rotational symmetry, so order of rotational symmetry is talking about if you rotate the shape, will it come back to its original shape? For example, this is a rectangle. So we want to get how many order of rotational symmetry it has. So if you rotate it, as we have it now, if I should rotate it like this, now this shape I have there, I've rotated it like 90 degrees, right? So it's not the way I placed it before. It's quite different. Let me do it again. So let me return it back to its original position. All right, this is the original position. Let me duplicate this and see. So this is it now. All right, this is it here. If I should rotate it here like this, 90 degrees, so you can see that this is the original one. Let me change the color of this so that you'll be able to differentiate. So this is the original one with this color, and this is the one rotated now. So you can see that it's not the same as the original one. So this one is not, we can't say it as, so we can rotate it again. If we rotate it again, you can see that I've rotated again. Now it's exactly the same thing with this one. So if they want to ask you how many order of symmetry, order of rotational symmetry does rectangle has, it has one, because you can only rotate it and it get back to its original position only once. Only once. You can't do it twice. You can't do it three times. So you can see that the first rotation did not give me the original position. The second rotation gives me this. Then if I should rotate it again the third time, you can see that it's not the same thing. If I should rotate it fourth time, it should not be fourth time. So you can see this go back. So it has how many other operational symmetry? It has two. So it has come back to its original position. So it has two lines of symmetry and two order of rotational symmetry. So we are still going to look at it in details later on. So I just want you to understand what is meant by line of symmetry and what is meant by what? Order of rotational what? Symmetry. So we're now going to go into the first one, which is a rectangle, all right? Which is a triangle rather. So we start with that one first. So let's go to triangle. So triangle, as you can see here, sorry for that. Triangle, as you can see, is a plane shape with three sides and three angles. So that's why you can see that. So triangle has three sides and three angles. Oh, sorry, I think I have to. So, So sorry for that. Sorry, excuse me. So it has three sides and three angles. So we're now going to start looking at the properties. And I said triangle has different types. I'm going to show you about 6 types of triangle in this video. So we're going to look at their properties one by one. So triangle is a three-sided plane shape with three angles. So this is first angle, second angle, third angle. So let's go to the types of triangles that we have. I hope I'm making sense. So in our video today is not that we don't have any calculation here, but it's something we just have to. We are looking at properties, so it involves no calculation. All right. So the next is types of triangle. So types of triangles that we have. But the first one we're going to look at is scaling triangle. Scaling triangle So scaling triangle. When it comes to scaling triangle, to try to understand it, scaling means something that is not equal. So if you are, now I used to say this, it's very funny to some students that you'll be able to know if some boys are chasing you and they are telling you that you lose scaling, you are looking scaling. They are indirectly using mathematical language to abuse you. You understand? So that means you are like amoeba. Understand that you are not equal. So when shapes are not equal, we call it what? Scaling triangle. So when you have triangle whose size and angles are not equal, when you are not equal, you are not like that means it has no shape. The shape is not that fine, beautiful, right? So that is what is meant by scaling triangle. So which means that this size are not the same. So this side uh, is not the same with this with the other side. So this side is not the same with the other side. So also, if you have this, you duplicate this. Uh, so if this has two lines, so which means these two lines, we have another one. We can bring this here. So where we bring this to this place, you can see this one has no line on it, and this one has one, this one has two. So which means all the sides are not equal. So also the angles are not equal. So this is a triangle whose sides and angles are not equal. So the first feature, the first properties of it is that no all sides, all sides are not what? Are not equal. All right. Then the second one is that all angles are not what? Are not what? Equal as well. All right. So all sides and angles are not what? The same. They are not the same. Then at the same time, can we have under this one, can we say it has a line of symmetry? And what is the order of rotational symmetry of this one? So it's also one of the things we want to look at again. So here, this, if we divide it, if I should bring a line here and cut it here, if I should cut it from here to here, all right, if I should cut it as I've cut it here, you notice that this triangle, the one at the top and the one at the bottom, cannot overlap. They are not the same. So in this case, so it has no line of symmetry. So that is another property. It has no line of symmetry. No line of what? Symmetry. Sorry. It has no line of what? Symmetry. So a scaling triangle has no line of symmetry. It has, so if we want to rotate it, if I want to rotate, let me duplicate it and see how if we can have other rotational symmetry. So let's rotate it and see what we're going to have. This is the first rotation. It's not the same thing. Second rotation is not the same thing with what we have here. Third rotation it's not the same thing. And the fourth rotation comes back to it. So the same position. So that means so let me delete this. It has, so the next one is what it has, you can see that it has one order of rotational symmetry. All right. So this is very important to understand it. It has one order of rotational symmetry. So these are the properties of a scaling triangle that we have here. I hope that is very clear. Then move to the next one. So the next property is isosceles triangle. Is isosceles triangle. We've looked at scaling. So isosceles triangle. An isosceles triangle is a triangle with two sides and two angles equal. So that would be the first property. Two sides and angles. Two two sides and angles. Two sides and angles are what? Are equal. All right. That's the first one. So the base angles. Now let me use this one to explain this. This shape here. We have this line here It's the same thing. This line here is equal to this line. It's equal to the other line here. Okay, so these short lines I wrote on this drew on it makes it to be equal. That this line and this line are equal. Then the angle facing the two lines that are equal are the base angle of the isosceles triangle. So isosceles means two angles are equal, so also two sides are what? Equal. So that means this angle here and this angle here are what? Equal. So those are the two angles that are equal. Then let's now look at line of symmetry of this. So how many lines of symmetry does this have? So how many lines of symmetry? So let's divide it. We can only divide it here. So we can divide it downward this way from the top downward. So you can see when you divide, you can see that this shape and this shape are what? The same. They're exactly the same. So an isosceles triangle has a line of symmetry. It has a line of what? Symmetry. All right, it has a line of symmetry. Then what about the order of rotational symmetry? This one too, we can only rotate it once and it comes back to its original position. So it has one order of rotational symmetry. One order of what? Rotational symmetry. I hope I'm making sense. So please, you need to take note of all this. Very, very important. So what else again can we bring out from this? So you can only have it once. So if I should divide it this way, it will not work. All right. So that is that on the isosceles triangle. So move to the next one. So the next one is equilateral triangle. Equilateral triangle. From the word equal, equi means equal angles, equal size. So all the sides are equal, all the angles are equal. Now, so if that is the case, all the sides, all the sides are what? Are equal. Then all the angles are also what? All the excuse me, all the angles, all the angles are also equal. All right. The another thing is that now, since all the angles are equal and we've done sum of angles in a triangle, so sum of angles in a triangle is 180 degrees. Now since all the angles are equal, which means we can divide 180 to 3, so that gives you 60, which means each angle is equal to 60 degrees. So each angle is equal to 60 degrees. All right, 60 degrees. Then so line of symmetry. So for this, so once you look at lines of symmetry, this one has. So let's look at it. We can see how we can cut it. So we can cut it from here to here. So if you look at it, you notice that what we have there, this triangle and this triangle are the same. All right, so that is one. We can as well cut it in another way. That is one line of symmetry. Then another way, we can as well cut it this way and see what we're going to have. Can you see? So this will also give us another line of symmetry. Can you see? So because this triangle and this triangle are the same, so we can as well cut it another way. So it can go this way as well. So this is another one. So meaning that it has how many lines of symmetry? It has 3 lines of symmetry. So 3 lines of symmetry. Because all the sides are equal, so automatically it will have 3 lines of what? Symmetry. So as we can see here, it has 3 lines of symmetry. So that's what we can have. So it has 3 lines of symmetry. It has 3 lines of symmetry. I hope that is clear. So order of rotational symmetry. So it's going to have three orders of rotational symmetry because let's try it out and see. Well, let's duplicate this and see. Let's bring it here. I'm going to change the color. Let's change the color now. So let's rotate it the first time. That's what we're going to have. So that's the first rotation. The same thing. Second rotation. It's the same thing as you can see. Third rotation. Let's come back to it's still the same thing. You can see. So it has three order of rotational symmetry. It has three order of rotational symmetry. I hope that is very clear. So those are the properties of equilateral triangle. I hope this is very clear and helpful. So move to the next one. We're almost done with this. So the next one is acute angle triangle. So we did acute angle in our previous videos, types of angles, and one of the types of angle we have is acute what angle. So acute angle is an angle that is less than 90 degrees. So this type of triangle is that each of the angles there are acute. So you can see that this angle here is less than 90 degrees. The angle here is also less than 90 degrees, and while also this one is also less than 90 degrees. So that is why it is called an acute angle triangle. So, and if you look at this, it's like scaling triangle. So all the sides might not be equal. So we can say all the sides are not, all the sides and angles are not what? Are not what? Equal. Oh, I'm making sense. So also, it has no line of symmetry as well. It has no line of symmetry. It has no line of symmetry, and it has, so it's going to have only one order. It has one order of rotational symmetry. I hope I'm making sense. So you can only rotate it once and it comes back to the original position. So let's try that out and see what we're going to have. So it's better for us to see it with our Koro eyes. Alright? So let's see things with our Koro eyes. So this is the first one. First rotation, you can see it's not the same thing. Second rotation, you can see it's not the same thing. Third rotation, is this third rotation, and the fourth rotation, if you come back to, you can see, so it has one order of rotational symmetry. So that is that on that one. So then line of symmetry, it has no line of symmetry. You can't divide it into two equal parts. No. So that is that on acute angle triangle. Then obtuse angle triangle is the next one. So the same thing, one of its angles. So this angle you can see here, this angle here, this angle here, this angle you can see here, this one angle here is an obtuse angle. It is an obtuse angle because it's more than 90 degrees. As you can see, it's not a square corner. All right. So that is why it is an obtuse angle triangle. So when you have a triangle that you can see one of its angle to be obtuse, so we call it obtuse angled triangle. And this one too, the same property with acute angle triangle. So all the sides and angles are not the same thing. All right. And it has no line of symmetry. Uh, it has one order of rotational symmetry. So that is that on this one. And the last one under types of triangle that we have is right angle triangle. So from the name right angle, which is 90 degrees, as you can see, one of its angle here is 90 degrees. So this is what we call right angle triangle. And under this one, we quickly look at some properties of right angle triangle. one of its properties here is that the angle, the side, the side, the side facing, because we are still going to use this property subsequently. So the side facing angle 90 degree, angle 90 degrees, 90 degrees is called hypotenuse. It's called what? Hypotenuse. It's called hypotenuse. It's called hypotenuse. So, and then the other two sides, the other two sides, the other two sides, the other two sides, the other two sides. So, which means we are saying that this side, this one here, okay, this one is not writing. So the other two sides are called, the other two sides are opposite, opposite, and adjacent. All right. So that is that on that one. I hope that is very clear. So the other one that we have is that this one has one line of symmetry. It has one line of symmetry. Line of symmetry. It has one line of symmetry. It has one order of rotational symmetry as well. It has one order of rotational symmetry. I hope I'm making sense. So which other one do you have there? Okay, I think that's all for this. So that is that in this video. So that is what we have for you in this video. So I hope you find it useful and helpful. So we're going to meet in our next video. We'll be right back. Thanks and may God bless you. Bye for now.